Hello, everybody, and thank you for joining us today to learn about the smart factory transition and how Industry 4.0 trailblazers have organized for success. My name is Andy Ellicott from Crate. I'm the head of marketing at Crate and have spent the last quarter century working with a bunch of data management companies, startups, launching them and growing markets for them. I love databases. My opinion, it's really the reason I love them so much is that new databases tend to unlock new software possibilities for developers, and they use the new data management capabilities to really create software and businesses that revolutionize the way we connect and live and heal and learn and do business. So, and creates the latest in that line of data management companies. I've been here for 2 years and look forward to covering the following today. I'm going to begin with a brief overview of Crate.io, just in case any of you are new to Crate and CrateDB. Then I'm going to talk a little bit about the operational brain in smart factories and really kind of how people are, some thought leaders and leaders in industry are using data to increase the effectiveness of their factories, efficiencies, and profit, and talk about some of the challenges that they face or faced in putting machine data to work, right? So, we're usually talking about technology and technology choices and how data management can help companies change the way they do business. But today we're going to focus a little bit more on some of the other half of the battle, which is really the change management process and how you have to organize to put data to work, and how you measure results and continuously improve your solution over time to help keep it relevant and valuable to the business. So it should take us about 30 minutes or so, and we'll end with question and answers if there's time permitting. So for those of you who are new to Crate, just a quick overview. We are in business to help companies put machine data to work. We were founded in 2013. We're the developers of CrateDB and the Crate machine data platform. Crate was first launched in 2014. Development began in 2013. It takes a long time to build a SQL database, which is what CrateDB is. So after several years of development, we launched the first general available version of Crate back in the end of December, end of 2016. So the product's been under development a long time. We have thousands of, over 1,000 deployments of Crate worldwide, and we're partnered with Microsoft to sell Crate on Azure. And throughout the years have won some nice awards like TechCrunch, Disrupt, and others. The company was founded in Dornbirn, Austria, and branched out to Berlin. So most of the engineering is in Berlin and Dornbirn, Austria and Germany, and also offices in the US in San Francisco and New York. So if you're not familiar with CrateDB, as I mentioned earlier, CrateDB is a new kind of SQL database. It's a distributed SQL database, which is designed to really handle bigger data problems like the ones facing smart factories. I'll talk about those in a minute. But it really helps people grow their database to handle more data, more users, more queries, better performance by scaling out and kind of in a cloud way, just adding, getting Crate to work on a bunch of cheap servers rather than bigger and bigger and more expensive single servers. We call that scale out or horizontal scaling. And the benefits obviously are cost. The other advantages of Crate, which include real-time performance. Crate is a columnar database, and which means that it is actually really good at answering questions about data. And because of the way Crate was developed, it's this distributed SQL database which stores data underneath the covers in this using technology called Lucene. It gives Crate the ability to do things like text search and also deal with JSON data or kind of non-tabular data. in a way that's very developer friendly. Just putting JSON documents in Crate. Crate will adapt the schema for you automatically, so you can have hundreds of different data structures inside the same table, which helps with database development, obviously. So if you're a factory with hundreds of different types of sensor readings, you can put them all in the same table and just query them without having to update your schema with each new data structure, and obviously get very good performance because you're not doing tons of joins across tables, although that's a possibility if you'd like. Okay, so that's a quick overview of CrateDB. If you want more information about it, happy to go into it. If you have questions, please feel free to enter those through the questions panel here. But let's talk a little bit about the operational brains right behind smart factories and what those look like. Why people build them. We'll talk about some of the technology implications of those, some of the choices you'll have to make, and how that can affect your IT organization. We'll also talk about how the implementation of these affects people outside of IT, right? The actual operators from the factory, and how to organize and how to help put this data to work. But when we talk about a smart factory or these operational brains, we're really talking about the software and the data management technology that needs to be in place to help these visionaries build smart factories, smart cities, smart vehicles, use lots of data, machine learning, artificial intelligence, or just plain old, kind of charts and dashboards to help people operate factories, in this case, more efficiently and profitably, more safely. Okay, that may sound like something a data warehouse would do, or kind of a data historian might do. True, but what we're really talking about now, these operational brains are like our own brains. Something that's really acting in real time. Okay, and we look at the data from sensors from your factory floor as stimuli, right? Really, just the same way you look at kind of stimulus to a creature with a brain. And that brain's going to process that using artificial intelligence, machine learning algorithms, data science, whatever you want to call it. In real time, look at that sensor, the data, that's stimuli, and formulate a response to it and put it into action, right? Like you would draw your hand away from a hot stove. Okay, but in this case, instead, we're going to draw a machine operator's attention to the fact that the machine might be using more raw materials than it normally does, or it might the defect count is starting to rise, right? So, and having them address that, within a few minutes instead of, kind of never or within an hour. Right? The reasons why companies implement these, the hope is and the expectation is that by using data from the factory floor, okay, and putting that into a kind of a dashboard or a format that people can act on right away, they'll be able to do things like improve OEE, operational equipment effectiveness, and other productivity measures in the factory. They'll be able to improve quality and therefore reduce the costs associated with defects, resource waste. Also be able to mitigate factory workforce turnover, okay, by using data to actually help new employees reach productivity much faster than they could without it. Right? Talk about how companies are doing that. Factory attracting workers, retaining them is a big challenge for a lot of companies, especially those with factories with high-end production equipment in remote or rural areas where skilled workforce or workers might be kind of high in demand and short supply. So using information to bring them up to speed faster is really valuable. Increasing safety and the security of of your facilities and your machinery, and really all of this tends to lead to increased profitability and competitive advantage. So these are just some of the reasons why companies, or how they justify the investment in new smart systems and operational brains that help put this factory machine data to work really in the moment. So technology, which we spend most of my day talking to people about, kind of technology options and technology choices to help implement these systems is really half the battle, right? You hear claims like, gain real-time insights at the speed of business, or you can create, put machine data to work. All well and good, very possible. These actually very realistic and noble aspirations. But the questions that leads to questions like, okay, so who's going to get these insights? Who puts them into action, and how? What do we do if people start to resist change? How do we measure the effects this is having so we can, kind of justify continued investment in it? And once we get that continued investment, how do we keep it relevant and valuable to the business and over time, so that we're doing something meaningful and important at work? I'm going to talk about one company in particular, one use case, one of our customers, and as follow-up, we'll share a report that a management consultant, Korn Ferry International, wrote about their implementation, their smart factory process. But ALPLA is, if you don't know them by name, you're certainly probably in contact with their products on a daily basis. They make plastic packaging for consumer product manufacturers like Coca-Cola, L'Oreal, Procter & Gamble, Unilever. So they make the bottles, okay? They have spent the last several years really kind of transforming themselves and modernizing their factories with data and intelligent systems like these, operational brains. The initial driver for them, the reason why they started to make this investment was workforce related. Like I mentioned before, they were facing just kind of high employee turnover costs, losing employees to resignation or retirement, and every time employee leaves the factory floor, there's institutional knowledge and expertise leaving the company. And the challenge was, how do we try and reduce that turnover? Certainly, but as long as it's happening, how do we help new employees climb the learning curve faster? How do we improve knowledge sharing and best practices across factories? In their case, they have 180 factories around the world. And how do we, can we create new career paths for some of our most experienced, factory operators? So those are some of the major, kind of reasons why they started to invest in this, was to help deal with the employee turnover. The big idea here was the development of a centralized mission control, right, where they would take some of their most experienced operators off the factory floor and put them in this lovely room you see pictured on the right, where they can now, with some learning, look at data that's coming from several factories and many production lines, and learn how to interpret that and really just kind of look at what's going, within acceptable and optimal ranges and what isn't. And when they see something that isn't, they alert people, operators on the factory floor, and step them through repairs and corrections and optimizations. Right. So I'll talk a little bit more about how they organize that and how that all works. But that was basically the big idea. Some of the benefits. One of the metrics that they put in place was how quickly can we discover and begin to address operational issues on the factory floor. For instance, the amount of plastic being used to create each bottle starting to elevate, or the number of defects starting to kind of, again, start to elevate beyond compared to normal operations. Before they put this operational brain in place, they calculated that less than 10% of these issues were found and acted upon within 5 minutes. Today it's well over 50% after this. So they're actually able to make process improvements and corrections many times a day instead of just a few times a year, right, which is what most people or most factories are capable of doing. The other benefits: new factory workers are up to speed faster than they were without these systems. They're able to share knowledge and resolution of issues across factories immediately, leading to sort of better overall kind of best practices adoption, development and adoption. And certainly, the factory productivity and was increased, and waste is reduced. ALPLA, back last year was piloting this in 3 factories, and they're on their way to having this support all of their 180 factories within the next 18 months. Okay, so let's look at a little bit about the technology choices that face them, how those technology choices may or may not affect your IT organization. Then we'll talk a little bit about the operations, kind of organization of operational staff after that. So systems like these operational brains, as we're calling them, have often using artificial intelligence or machine learning. They have a huge appetite for data, right? So in ALPLA's case, we're talking about 950, I think, different sensor types in each factory. Okay, this kind of the analytics we're running here, mainly time series. Okay, for all these different sensor types, and again across all factories, but also natural language processing. They're looking at resolutions and stuff. This system they built looks at natural language processing, like doing basically text search to find issues and ways to resolve issues in their online manuals, and integrating this operational data with IT data from ERP systems and HR data. Like, can we see if there are correlations between better or worse factory performance and the people who are on duty, right, during those periods, which comes from their HR information system. Can we do the same kind of analysis based on the provider, the supplier of certain raw materials, right? Is that affecting quality or productivity? So the ability to integrate this mainly time series data from the factory floor with contextual data from other systems in IT is really important to them. And this seems to be people talk about the IT and OT convergence. This is really what they're talking about. The volume of data here, so data variety, yes, data volume, obviously, and we're talking about millions of data points per minute when you talk about collecting this data from factories that run 24/7, and you're talking about production of millions of products per day from each production line. Okay, so if we put that simply, we're talking about a data management system or an operational brain that has to process a fire hose of, we'll usually say, weird data or complex data in real time at the edge in the cloud, right? But again, huge volume of data, wide variety of data, and really you're querying that or analyzing it and interpreting it really as the data is flowing into the operational brain, so that you can discover problems and address them within that 5-minute period that, say, ALPLA had. Okay, if you're in IT, you know this, right? Your database choice is critical to success. It's just the old choosing the right tool for the job. You can hammer a nail into wood with a lot of different things, but hammer usually works best. The problem, though, or the challenge, is really that there are 50, 100 different database options in the cloud or downloaded on premises available to people today. So making the right choice for these operational brains is a challenge, and which will affect the overall cost of the system, how quickly you're able to deliver it, how quickly you're able to get it to adopt or support new business requirements. Again, if you're in IT, this is kind of old news, but again, it's if it's been a while since you've chosen a database other than Microsoft SQL Server or Oracle, you know that you've got a lot of options out there, and making the right choices requires a lot of knowledge of what's available in the market. Okay, to help you with some of those, just kind of talk a little bit about some of the myths and realities of data management platforms for the operational brains and smart factories. Myth number one is that this is not a new data problem. We can use the database we've been using for the last 10, 20, however many years to support this system. We can do it with a data warehouse, or we can do it with a data historian. Again, probably true, but again, it comes to using the right tool for the job. If you want to do this quickly and cost effectively, and kind of with a lot of agility and responsiveness to the business, you're probably going to want to choose a database other than the ones you're using. The new data management platform may work with the existing databases, but traditional SQL databases like Oracle, MySQL, Postgres, SQL Server tend to be too slow to handle this kind of volume of data, this fire hose of data, and really querying it as it comes in. They're just not meant to handle these streaming kinds of use cases. Traditional and streaming and time series use cases. Traditional data historians are great at handling this data. But however, they tend to be too costly and too proprietary to make integration with IT systems like the HR systems, or the ERP, like I mentioned earlier. That integration tends to be pretty hard to do. They tend to be expensive. The historians are kind of 20, 30 years old, still run on premises. To grow them is expensive, and sometimes to add support for new sensors or tags, as they're called sometimes, can be quite costly. So you tend to want to, a lot of companies tend to be looking at new databases or alternatives to those two categories of databases for these systems. And many of them think, okay, this is a NoSQL problem. Let's use something like Elasticsearch or Cassandra or MongoDB. While true, one of the things that's changed over the last 5 years is that SQL databases like CrateDB and others have borrowed technology and learnings from the NoSQL era that allow SQL to be used, SQL databases like CrateDB to be used to and deliver the scalability and the ability to deal with all these kind of unusual requirements like time series and JSON, all these different data structures that come off the factory floor, and handle those gracefully and economically and easily. So you really don't need to give up SQL to gain the scale and data flexibility that the NoSQL databases tended to provide. Third myth, this is a time series problem. Again, reality, fairly true, right? Time series is definitely a requirement in these systems, and what we mean by time series is really analyzing, say, sensor readings or things like defect rates or temperatures or what have you over time, by the min, max, average, or even more complex analyses, by the hour, by the minute, by the bottle in ALPLA's case, right? So analyzing this timestamp data and looking at stuff over time, really in real time, is a challenge, and there are specialized time series databases that are capable of that. The problem with them is that they tend to be a little too specific and specialized in just time series. They also tend to not be SQL, right? Which for those of you who work in IT know that makes learning them and integrating them and accessing them quite a lot harder because they require specialized tools to be integrated and to have their data viewed and reported on and analyzed. So there are not all time series. Time series is not a one-size-fits-all problem. Time series databases aren't. There's some variety there. Crate is what we would call an industrial time series database with the ability to handle that variety and volume of data, and not just the volume. And I think the last sort of myth we hear from people quite often is that we really can't start an operational brain or smart kind of really put AI or machine learning to work on our factory data until we improve our data hygiene or our data quality. So we work for data quality. Truth is, I think what we see companies doing, the ones who are kind of bolder, or they just say, yeah, that maybe that's a problem, but if we wait until our data is cleansed, we'll be waiting forever, right? This is a problem that a lot of companies have faced for decades, right? And that's a persistent challenge. So, my advice is to get going, right, and really cleanse the data as you go, which is part of the QA process, and kind of understanding what the data is telling you. You're just, as with any software project, you'll understand whether the data is telling you something because that's the way it is and it's a new insight, or no, we kind of looked at the data and the sources of that, the provenance of it, and realized that no, the data just needs to be cleansed a little bit. Then you make that correction and then iterate. Okay. So there's just a couple of thoughts on technology. So this big scary picture is what the data platform for one of these operational brains looks like. This stuff in blue. Okay. No matter what database you put inside there, whether it's CrateDB or anything else, all this other stuff is going to be there, right? And to build this today, right, especially if you're building a cloud platform to integrate data across many factories, like ALPLA's done, across global, kind of footprint of 180 factories. Your IT department's going to need to be expert in technologies like containers and distributed computing and DevOps and data security and database architecture and cloud engineering and blah, 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 all the things you see listed on the left, sometimes collectively referred to as cloud native software stacks. So so if your IT organization isn't already expert in this, don't worry. Okay, this is it's an expensive kind of a set of skills to own and to hire. The good news is that a lot of these skills are already available as a service from cloud providers or IoT data platform providers like like Microsoft Azure on the cloud platform, Crate and the IoT data platform. So all of those things, like I just mentioned, are really kind of already taken care of for you in hosted services, like say Crate machine data platform, or Microsoft Azure and Azure IoT hubs and stuff like that for connecting devices to the cloud. And so all your IT department really needs to be expert on is the business specific stuff, like really kind of how do we what does our data mean, how do we visualize it, what are the end user requirements, and kind of how do we analyze the data, how do we enrich it, how do we integrate it with other systems. So you really, if your IT department is saying we need to kind of hire a whole bunch of experts in these technologies and we're going to build something that looks like this blue box from scratch, I would push back a little bit and maybe suggest a cloud offering which will help you start to kind of reach production and start to see benefits probably many months to a year plus sooner. Okay, so that's a quick thought or two on the technology. If we switch now to kind of the non-technology side of it, the other half, right? How do we organize? How are people organized? How are results measured? How do we keep this relevant and valuable over time? Let's start with organizing people. One of the things that ALPLA did was they started with a metaphor, right? So they wanted to launch this initiative within the company, and they chose a metaphor to make it fun and really understandable by the business, a lot easier to understand than all the jargon I just went through on the technology side. And the metaphor they chose was a rocket launch, right? Just really, kind of let's launch this new era. And they came up with a bunch of names kind of tied to that theme. First was mission control. And that guy you see in the picture in the upper right is one of the members of, he's working in mission control. They staffed mission control with factory floor experts. So this is actually a new, I believe, white-collared job for the for the factory floor experts. And I think one of the really important, this is a critically thoughtful decision, right? Rather than putting a data person there or a process engineer, they really wanted to put people who had the respect of their peers on the factory floor and who really understand how to resolve these issues in case that's required, so that they could really share their knowledge and mentoring with people on the factory floor. It was just an easier all around, kind of train these people on, kind of the meaning of these dashboards and how to understand what the data means. They kind of already know it. And again, the next challenge was to connect them to the people on the factory floor. So in this mission control, which is at their US headquarters, they're informed by these dashboards, mostly kind of just showing how, defect rates, a whole bunch of operational parameters for each factory. I think something like 5 or 6 dashboards per factory. And when they see an issue, right, they issue an issue arise, like say defect rates starting to kind of rise outside of normal kind of ranges for a factory. They'll send a note to somebody on the factory floor through tablets through this actual system, and those notes arrive to the people on the factory floor, usually through a tablet they carry. And those people on the factory floor are called heroes, okay, just like the space explorers. Another important thing that having these, the people in mission control understand that not all factories work alike. Okay, there are some factories that are test beds for new processes, new technologies. Others who aren't. Some newer factories are still they have less experienced staff. So the mission control understands that, and they can come up with they can interpret the data they're seeing and kind of take corrective measures based on their knowledge and understanding of these kind of things that make each factory unique. So as I mentioned, the heroes are the operators on the factory floor. And then this last and probably most interesting part of the metaphor is going on a spacewalk. Okay, and what you see depicted in the bottom right is a Microsoft HoloLens, and this is where this gets really cool. When one of these, the mission control people can actually step a hero through the repair or tuning or optimization or restart of a machine, and in the process see what that hero is seeing on the factory floor. So the hero would put on the Microsoft HoloLens, which is an augmented reality device, and the person in mission control can see what they're seeing, can annotate their field of vision, right? Can draw circles and arrows and stuff, point to things on the in their field of vision, and help step them through these repairs much more quickly than they could do on their own. Okay, and the other thing on here, I'll actually talk about the knowledge sharing because it's related to what I was just talking about, is that every note, right, every issue has a note sent to the factory floor. Every note gets resolved, and that resolution is, they're very strict about this. Every resolution is documented, okay? And the documented fixes, repairs, what have you, process changes are logged in the system, and they're automatically distributed to the online manuals in every factory. So when you're looking up, kind of how to do X or Y or Z on the factory floor in the online manuals, you're also seeing sort of best practices and things that can go wrong and how they were fixed from different factories. So this knowledge sharing that goes on, and this mentoring that happens, for the heroes by Mission Control is really helping ALPLA, kind of bring its new employees up to speed much faster than they could in the past, which helps with the turnover they were experiencing, and also just makes every factory better, as they can all share best practices, and almost like the way we learn which restaurants are better than others through kind of peer reviews and comments. Okay, the top bullet there, carrots and whips, not as with a lot of IT systems, not everybody's on board with change. So, in some cases, it may be important, it's certainly important to have executive leadership behind this initiative. Certainly we're kind of forming a new functional group within the company, like the Mission Control. And they really have to be bought into the results, and you need to show results quickly. I'll talk about that in a moment. Because in some cases, there are going to be people who are just not into it's like, okay, thanks, Mission Control, but yeah, I know how to run my factory, right? So those situations exist, and that's just where management's got to just crack a whip and say, get with the program, and force the resolution, kind of issue resolution to be documented and all that stuff. So it can take a heavy hand in some case to get people to change, but that's hopefully those occasions or those instances are few and far between. Should be the case if you're doing a good job of documenting the benefits and positive results that the system is achieving. Okay, so let's talk about that. So part of the deployment and rollout of this, for ALPLA and other companies we've worked with is really a process of calculating the value for every resolution. Okay, so looking at the possible issues, the possible resolutions of those, and coming up with a very conservative estimate of the value each of those will have, in either per minute, per unit. So, if the difference between fixing a problem within 5 minutes versus 1 hour, or how long it used to normally take, can usually be calculated pretty cleanly, in a company like ALPLA or any discrete manufacturing company, in terms of the the productivity gained or opportunity cost, not lost, by downtime, by defects created and all the raw materials wasted with the defects, and the opportunity cost associated with producing defective products or nothing at all. So coming up with conservative estimates of those. Important to be conservative, because you don't want anybody challenging. You just really want this data, especially in early days, to really be bulletproof and kind of very defensible. So you can get buy-in from management into these metrics and the value that you're really documenting every day. And we see most of the customers with really just looking on a daily basis. They're updating these values either manually or they systematize it. But they're looking at the value they're creating and really, again, being honest and conservative about that value and the relationship to the costs, right? Not just the top technology acquisition costs, but the staffing costs, right? The cost of Mission Control in ALPLA's case, and really comparing those two. And the benefits are, they definitely roll in, right? I can't go into details, it's confidential, but the companies we work with are really seeing very substantial quantified results. So the last thing I want to talk about is continuous improvement. Okay, so really being agile, and if you're from IT or software development, that's a carefully chosen word. If you're not from IT, then I'll explain that agile is a methodology or a method of building things, software. Okay, And it's an approach that really kind of captures the following points or processes. And it's something you can really engage your business people around to help make sure you're building new insights and adding new capabilities to your operational brain that are really meaningful to the business. The process at a really kind of high level, you work in very short sprints, right? So there's usually multiple weeks, 2 weeks, 4 weeks. And, as you're on a steady basis, you're capturing new requests from users, new requirements, new bright ideas from people as stories. So you're really going to talk about how, Andy, the operator, felt like he would benefit from, kind of this information, or says that we have this issue on the factory floor a lot, and it's causing kind of defect rates to go up, and it would be great if we could get a heads up on those issues. It just seems to be an issue that happens that we never really kind of hear about from mission control. And if we had that, we'd be able to correct this problem we were never really alerted to within 5 minutes, and this probably happens 3 times a day, etc. So kind of by documenting that story very clearly, you can really understand who's affected by this and what the value of that kind of request is. And on a regular basis, like again, every few weeks, you sit down with the business people and technologists together, and you score and prioritize these items and really schedule what you're going to try and build in the next sprint. Then you build that, deliver it, and hold a retrospective on it. Like, did we do a good job of building it? Was there anything we could have done differently to build it faster, easier? Did Andy, the requester in this case, get the benefits he was expecting? If not, why not? What could we have done differently about capturing the story or the requirements to have helped us, improve this? And it's really the process itself of this continuous improvement improves as you go along. But just doing this iteratively over time and really, forces the business and technologists to come together and keep this relevant and valuable as the business evolves and as kind of factory processes and equipment and people change and practices change over time, regulations change over time. So, this is it's vital to the ongoing improvement of the system. Okay, so a couple of closing thoughts in summary here. Number one, the operational brain is something that's, if you're not already implementing these in your business or your clients' businesses, they're proving to be pretty valuable. They really allow business to make course and process corrections on an hourly basis and not just quarterly, like kind of a lot of the systems, the legacy systems, which give you kind of data warehouses, which give you kind of a rear mirror view of production. And the benefits really include gains in efficiency, safety, and workforce management that really contribute to profit and competitive advantage for companies. Change management, keeping in mind that these operational brains and the technology underneath them really drive people. So you really need to organize and gear up for success. Crate obviously here to help. We're really the technology provider. If you or a company you work with is in the business of helping companies kind of adopt new technology and guide them through this change, we work with partners to do that, and welcome anybody who's listening today in that kind of business to ping us. We have a partner program to team up on projects like this together. Okay, so I see we're a little bit over the time we had planned here, just 45 minutes. We just have a few questions. I'm going to take 1 or 2 of these, and then the others I'll just do through. We'll follow up with you after this. The question was, one question here is, how does Crate compare to InfluxDB. InfluxDB is a newer time series database, and it really falls into the category of a specialized time series database that I mentioned earlier. It's probably one of the best known and the new time series databases. It's Crate is really and Influx really grew up in the IT systems monitoring realm. So it's great if you have a kind of smaller amounts of data, smaller variety of data, like you see in IT systems monitoring. You have kind of tens of metrics like CPU utilization, disk utilization, stuff like that in your, say, your cloud or your IT infrastructure. It helps them with uptime and failures and stuff, kind of all the machinery that runs IT. That's a smaller and simpler problem than factory floor and industrial time series, and that's what Crate's designed for. So the difference between the two of them is Crate's just better suited for time series problems that have, say, terabytes of data, not gigabytes, and also where you need to integrate your time series data with or where you have like maybe hundreds of different time series structures, sensor types. Crate's a lot more extensible than InfluxDB, and a lot easier to integrate. Crate supports SQL and Influx doesn't. Okay. I'm going to call it there. There are a few other questions. We'll follow up with you after the on an individual basis, but want to thank you for joining us. In the next few weeks, we'll be scheduling a webinar that goes more deeply into this idea of industrial time series versus it's kind of a special use case for time series, and we look forward to seeing you there. Feel free to visit Crate.io if you'd like to learn more, or ping me directly if you have any questions. And we'll follow up with a link to these slides and a recording of this webinar, as well as that Korn Ferry report on ALPLA that I mentioned earlier. Okay, thank you very much, and good luck with your smart factory projects.